Hello everyone, we are Jinghe Technology. This video continues to introduce programming. As mentioned in the previous video, all the screw hole coordinates need to be inserted into the handle. Now we have inserted all the coordinates of the left LED module screw holes into the handle. Now we need to copy the screw hole coordinates of the LED module on the left to the LED module on the right. We move the yellow cursor down to the blank coordinate position. As shown in the figure, the screw hole coordinate parameters at the yellow cursor position have not been configured. Then move the X and Y axes to move the CCD camera onto the LED module on the right. Move the first screw hole on the right to the center of the red cursor. This is toggling the Y axis. You see, now Y1 is moving. If you press the switch Y axis, it will change to Y to moving. This shows Y1. If I need to switch to Y to move, I need to press this toggle switch. Here are the coordinates of Y2. I press the Y-axis direction, and now the LED module on the right is moving. Now we move the first screw hole to the center of the CCD red cursor. When you are about to reach the center of the screw hole, switch the speed to slow. Now we need to copy all the coordinates of the left LED module to the right LED module. Click the Copy button. Click on the pop-up window. The LED module on the left has a total of 32 coordinates. Start address, enter 1. Press the down button to end the address and enter 32. Copy to address and enter 33. Since the blank address is 33, the copy address is 33. Click OK and all the coordinates are copied. Click OK. When you press OK, the machine will prompt you to move to the first coordinate center position of the corresponding screw hole. We are now at the first screw hole location, so just press the OK button. The coordinates have been copied. But we need to check whether the copied coordinates are in the center. Press the down key, then press the move key. The CCD will move to the coordinate position of the second screw hole. Press the down key to move the yellow cursor, then press the move button. Click the move button and the CCD camera will move to the cursor coordinates. Check if it is in the center, if not, move to the center. After moving the screw hole to the center position, click the coordinate keys to update the coordinates. It will replace the original coordinate values. Then the yellow cursor will automatically move to the next coordinate. Then we click the move button to move the CCD to its current coordinate position. We check the display to see if the screw holes are in the center. We move the screw hole to the center of the red cursor. Then press the coordinate keys to modify it. It updates the current coordinate data and then automatically jumps to the next coordinate. But the actual location requires us to press the move key to reach the actual location. The machine will move to its actual location. Next, we continue to move the screw hole to the center of the cursor. After moving the screw hole to the center of the cursor, press the coordinate key to replace the original coordinate. Then the cursor automatically jumps to the next coordinate, and then click the move key. The coordinate key can only be pressed once, not twice. Pressing it twice means inserting two identical coordinates. We need to check the coordinates of all the screw holes of the right LED module to see if the screw holes are at the center of the cursor. Using this method, all screw hole coordinates are inspected and calibrated to the cursor center position. If you still don't understand, we can look at the order of the steps the engineer's fingers follow. we need to move the screw hole to the center of the red cursor. Okay, we've now checked and calibrated all the screw hole coordinates. Then press the reset button to return all X and Y axes to the origin position. Next we need to set the screw assembly height for the Z-axis. If we need to check the coordinates of all screw holes. This is the previous page, down page. This is up and down. Up page, down page. Click to go up 10 lines. Click here to move the cursor once. Clicking up allows only one move, and clicking down also allows only one move. Next we want to set the height of the coordinates Z-axis. We are going to set the assembly height of this screw nozzle. Set this nozzle height. First open the navigation interface. Click to go down. Click to go down. Find this user level operating parameters. Then click OK. Find item 9 settings visual camera parameters and click OK. Do not modify the parameter data of this page. Click down, we want to modify this moving base. We changed the moving reference from the camera to the screw nozzle, because cameras were used to locate the screw hole coordinates before, so we're going to switch to option 1, then click OK. By switching the screw nozzle, the assembly height of the screw can be obtained. I select the coordinates of the screw hole and click Move. Now the nozzle moves to this coordinate position. Previously, after clicking Move, the camera was aimed at the position of the screw hole, and now the nozzle is aimed at the position of the screw hole. We use this nozzle to measure the height that needs to be assembled. Then adjust this Z-axis speed to medium speed. When the Z-axis height is about to approach the LED module, the speed needs to be switched to low speed. Switch the speed to low. Then click on the Z-axis to slowly descend. Method for setting the Z-axis height. Insert the protruding screw into the screw hole. This position defines the assembly height of the Z-axis. Now let's spray a screw out to demonstrate. The Z-axis assembly height is set by inserting the small protruding part of the screw into the screw hole. For better viewing, we switch to the second screw hole coordinates for better viewing. The pointed end of the screw is inserted into the screw hole, but the screw cannot be inserted completely, only a small part is inserted. It is difficult to observe with a camera, so you can only check this height with your naked eyes. The tip of the screw needs to be inserted into the screw hole. We need to insert the tip of the screw into the screw hole. The tip portion is inserted into this screw hole. We can only observe it with the naked eye. When this position is reached, this is the assembly height of the Z-axis. Let's now look at the Z-axis height value on the handle. Record this height value and click Batch Z-axis settings. Introduce again. When the tip of the screw is inserted into the hole of the screw, observe the height of the Z-axis, and then record this height. Open this Z-axis setting. After clicking, the window pops up. Start address coordinates, enter 1. The end address represents the last coordinate. Since there are 64 coordinates in total, enter 64 or 100. And then we input the height in the Z-axis. 76.4. Then click OK. You see all the Z-axis heights have been modified. And then we click on the Z-axis height up. When the safe height is reached, we click the reset button again. In this way, we have modified all the z-axis height coordinates. Next, we need to change the moving reference back to the original parameters and switch the moving reference to the CCD camera. Switch to camera. Click the navigation button. Find this user run parameters. Select item 9 and click Set Visual Camera Parameters. Click the down button. Change this parameter to Vision Camera. Enter 2 and click OK. When we select the screw hole coordinates and click Move, the CCD camera moves above the screw hole rather than positioning the nozzle above it. Only switch to the screw nozzle when the z-axis height needs to be detected. Before assembling the screws, we first set the servo configuration parameters and adjust the torque to the minimum of 30. Set the tightening torque of the screws to 30, then click OK. Next, we assembled the screws. Then move the yellow cursor to the first screw hole coordinates. Then click single step and the machine will automatically assemble a screw. Click single step and the machine will automatically assemble a screw. We click and we look. At this moment, the machine sounds an alarm. The problem is that when the screw nozzle is lowered, it suddenly rises up and sounds an alarm. This shows a floating lock alarm, which means that the screw is not assembled properly. During the screw assembly process, the servo motor detected that the target torque of 30 had been reached, but the screw was not fully tightened, which triggered a floating lock alarm. When such an alarm occurs, we need to stop and check the cause of the problem. Now we need to modify the parameters. Select servo configuration and click OK. We need to set the tightening torque of the screw a little bit higher. Adjust the torque value from 30 to 35. OK. Select the coordinates and click single step again to check the screw locking status. Select servo configuration 1 to modify the screw tightening torque, set it to 35, and then click OK. Select the coordinates of the screw hole and click single step. The machine sounds again. This is an error in the timing of the assembly screws. You see, the screws have been assembled, but the alarm still occurs. Because it completes the screw assembly in 0.3 seconds. We select time settings, click to open, and modify the parameters to 0.2. This means that if the screws are assembled within 0.2 seconds, an alarm will be triggered. Select the coordinates and click single step. Now it works, the screws are assembled and no alarm occurs. If you want to see every movement of the machine clearly, you set the speed of the X, Y, and Z axis to 100. In this way, when the machine is running, the speed is very slow and you can see it very clearly. After the debugging is completed, we will resume the working speed to normal. After clicking single step complete, we need to manually check whether the screw is assembled properly. If the alarm occurs again, we click cancel and then troubleshoot the problem. Because this module has been debugged repeatedly, we are worried that the threads have been damaged, so we tighten the screws manually to check. If an alarm occurs, we hit the cancel button. This screw has not been fully tightened yet. This means that the torque parameter we set is too small and we need to increase the torque. Select the servo configuration, click OK, and set the torque parameter to 40. Torque should be increased to 40. Click OK. Select the coordinates that do not have the screws assembled. Check which screw holes have no assembly screws. Then click single step. After the screw is assembled, tighten the screw manually and check it. The screws are about to be tightened, but a little more torque is required. When we click on the single step, be sure to check whether there are screws at this coordinate. We continue to increase the tightening torque of the screws to 45. We select another coordinate without assembly screws and click single step. We manually check again whether the screws are tight. The tightening torque this time was a bit too high, causing the threads to be damaged and the threads to slip. Because these screw holes are often tightened and then removed, it is easy to damage the PCB threads. When the thread of the PCB is damaged, the machine will automatically sound an alarm to show that the screw hole is damaged. We need to reduce the tightening torque of the screws. Because this PCB is repeatedly tightened, it is easy to damage the alarm. This shows a tooth slide alarm. We set the tightening torque of the screws to 40. If you don't know which screw hole coordinates have been assembled with screws, you can click the Move key to use the CCD camera to check. We click on the next coordinates to check if the screws have been assembled. This one already has screws. If there are no screws on this coordinate, we click single step. This alarm was triggered because the torque was too high and the teeth were slipping. The PCB threads are damaged. PCB screw holes cannot be assembled or disassembled multiple times, as this may easily damage the threads. If the machine alarms, but you want to continue to operate it, just click the Start button. You can press Cancel or go back to the original point. We select another coordinate, click single step, and continue to assemble the screws for viewing. The yellow cursor jumps to the coordinates where there is no screw. I don't want to continue clicking single steps, so I can directly press the machine Start button. Press the left Start button for the left module and the right Start button for the right module. Check whether the current coordinate is Y1 or Y2. If it is Y1, press the Start button on the left. If it is Y2, press the Start button on the right. Sorry, one action is missing. Suppose this module has completed half of the screw assembly, and I don't want to click single step and assemble the screws one by one. I want to automate the rest of the screw assembly. Move the cursor to the coordinates where there is no screw, and then click the cursor Start key. This is the cursor Start key. I just simulated it. If I press the Start button of the machine directly, the machine will assemble the screws from the beginning. If we need to start assembling screws midway, we select the coordinates without screws, then click the cursor to start, and then press the machine Start button. Y1 press the left to start, Y2 press the right to start. The machine detects a slippery screw and issues an alarm. This is because the air is blowing too hard and the screw is blown off course. We remove the screw on the nozzle. If the nozzle does not have a screw, we press the driver test on the machine. Press the driver test button and the machine will start working again. If it is a false alarm of the machine, there is no problem with the alarm. We can directly press the Start button and the machine will continue to work. After all the screws of the left LED module are assembled, we check the tightness of the screws. If there are no problems, we continue to complete the right LED module. After checking that there is no problem with the LED module on the left, we directly press the Start button on the right of the LED module on the right. The machine gave an alarm. First press the machine's stop button, then press the reset button to return to the home position. The height setting for the Z-axis is to high, causing the tip of the screw to fail to engage with the screw hole, resulting in misalignment. As the screw hole coordinates were not centered on the red cursor, the screw failed to engage with the hole during descent. We need to align with the coordinate center of the screw hole, then set the Z-axis descent depth. We are increasing the depth along the Z-axis. Z-axis descent depth increased from 76.4 mm to 76.9 mm. We check if there are screws on the nozzle. If there are screws, remove the screws. Let's introduce what the buttons on the machine mean. This is the start button. After we place the LED module on the left, press the start button to start production. After the LED module on the right is placed, we press the start button on the right. If there is an abnormal problem, press stop and reset. Press the machine reset button to return to the origin position. If the ray lock key is pressed, the cylinder moves downward. Extend the screw tightening tools. This is the cylinder retracting down or up. In the stopped state, the screw tightening tool rotates when the drive test is pressed. If an alarm or fault occurs during operation, we press the drive test button and the machine will be reassembled with new screws. If you press the drive test button in the stopped state, the motor will just rotate without any other movements. If during normal operation, the machine has an alarm, such as a slipping alarm, or if there is no screw on the nozzle and it keeps running idle, the machine will also alarm. We check if there are any screws, press the nozzle to open it. If there are any screws, remove them. Then press the drive test button. The machine will insert an additional screw at the original coordinates before resuming operation. The screw feeder button must not be pressed whilst the machine is in operation. If the machine is in stop state, we press the button of screw feeder, and the feeder will send a screw to the nozzle. We can only use the screw feeder when the machine is stopped. Press the screw feed button once and the machine will feed a screw. We need to take out the screw before we can continue to press the screw feed button. This concludes our machine programming video. Thank you for watching. See you next time.